Okay, so my NASH project was to build a neural field synthesizer. The idea is to take a big data set of one-shot audio samples and then encode them continuously in a neural field where you can access them with high-level features. And to do so, the model decomposes the signals into harmonic and noise components using a sort of continuous wavetable or wavespace and a filtered noise source. And the whole thing is continuous both in terms of controls and inputs. A neural field basically is a neural network that parameterizes a field. So it just has a value at all spatiotemporal coordinates within a system. And you can represent things like, say, images by taking in XY coordinates and outputting RGB pixel values. Here I'm using a model called Siren to do this, and I'm bending the definition slightly and using things like phase or coordinates in an instrument space as input and getting synthesis parameters out. Phase over time is passed in just by projecting it onto the unit circle, giving us these spirals, more densely packed, means higher frequency. And this lets us sample a wavetable with no discontinuities whilst giving smooth evolution over time. It also learns a simple linear projection from our one-hot encoding of the instrument label to a 2D instrument space. So my first attempt looks like this, basically applying film conditioning to the activations of the sirens. And it kind of worked, but it was also very sensitive to hyperparameters and collapsed a lot. So I simplified and instead just trained bigger sirens that took all the control information I had as input, and this worked way better. So it can do things like reconstruct. Far from perfect, but not bad. We can interpolate in the instrument space. And we can even sample randomly from the model. A few things I noticed. Sirens are really good when they can see the whole space they're fitting at each optimizer step, but mini batch gradient descent makes them super unstable. I noticed that the models kind of stopped using the noise synth later in training, but they used it a lot in early stages of training, possibly because they just get stuck in the many local minima of the periodic loss surface. Also, just having two independent representations for the stochastic and the noise part and the harmonic parts is probably very silly, and maybe some weight sharing would have helped. And also, like, all of the pitch information is just coming from the note annotations in NSynth at the moment, so probably would do a lot better with a proper F0 estimate. Next up, I want to try some other neural fields. Sirens are very unstable, but there are things like multiplicative filter networks that are a little easier to optimize. Obviously, try that weight sharing. Also, it'd be cool to go the other direction and step up from film and maybe learn a prior over the weights with a hyper network, because that's been working really well in image representations. And similarly, we could try and train adversarially, as was done in Pygan. And then also, yeah, this needs an interface to play with and explore the sounds. And that was my project.